aromatic system, say phenyl group is nothing but a benzene ring, they are called phenols. So, alcohols and phenols, they belongs to the same functional group called what a hydroxy functional group. They are hydroxy compounds in fact. However, the hydroxy group when you have a ROH, the H is replaced by another alkyl group, then we are calling a ethers. So, ethers will have a totally different functional group, however, they are derived from the alcohols, therefore, commonly the ethers also studied with the alcohols. Today, we will focus on the alcohols topic. So, we have a alcohols classification. First point, that is, alcohols may be classified once again into three types. Alcohols containing only one alkyl group attached. The hydroxy group containing carbon has only one alkyl group or no alkyl also. All hydrogens containing only, there is no alkyl group, both are called 1 degree or primary alkyl, primary alcohols. Primary alcohols. If the OH is attached to a carbon where two alkyl groups are there, two alkyl groups, such a alcohols are called secondary or 2 degree or secondary alcohols. Secondary alcohols. The OH attached carbon, if it is attached with 3 alkyl groups, the alkyl group may be a starting from methyl, ethyl, propyl and very big group you can take. It can be an aromatic also. But the carbon attached OH is attached with 3 alkyl groups, it is called 3 degree. That is also called as tertiary alcohols. So, there are 3 types of the alcohols are there: primary alcohols, secondary alcohols and tertiary alcohol, because they have slight difference in the oxidation and their relative reactivity and the dehydration, they are slightly showing different properties. Even in the preparations also, slight variations we require in the preparation methods also. That is why we have a classification here: primary alcohol, secondary alcohols and the tertiary alcohol. An example here I will give: a butane containing a OH on the one of the carbon, then can you tell me what type of alcohol it is? Means the OH attached carbon has one ethyl group, one methyl group, one hydrogen. It is not the hydrogens, but how many alkyl groups? 2 alkyl, therefore it is 2 degree alcohol. In fact, it is also called a 2-butanol. The 2 does not refers to the 2 degree in fact, isn't it? It is not a 2 degree. For example, if this compound is changed, and let it be like that, I will write one more compound. This is also 2-propanol, 2-methyl 2-propanol, 2-methyl 2-propanol. So, the 2 is not referring the degree. Here 2 is okay, 2-butanol is nothing but 2 degree you can say, but here it is also 2-propanol, but the system is here the OH attached carbon has 3 methyl group, therefore it is 3 degree. This is okay, 2 degree. So, the position is not the actual criteria, but the OH attached carbon, for this carbon how many alkyls are linked? If 2 alkyls are there, let maybe one methyl, one ethyl, or both are ethyl, I am not a particular, but how many alkyls? 2 alkyls, 2 degree, okay, it is 2 degree, 3 alkyls, it is 3 degree. Any alcohol and the one of the end of the carbon will be naturally a 1 degree alcohol, okay. So, this is the classification of the alcohols. Now, let us go to the some of the preparation methods of the alcohols. How alcohols are prepared? The alcohols can be prepared by the hydrolysis of RX. RX stands for the alkyl halides. The simple example is ethyl chloride when you take and boil with the aqueous water soluble dissolved sodium hydroxide and boil it for some time. The OH makes a substitution reaction. OH minus will replace the Cl. It happens to be a nucleophilic substitution reaction. Further details we have seen SN1 and SN2 and so on. This is a simple compound, therefore follows a SN2 type of the mechanism. OH replaces and the Cl and the new OH group, that is nothing but a ethanol. You need not to say one ethanol, because the OH this side also it will become one ethanol. Unless there are two OHs, it is a glycol, but one OH means it is a ethanol. You need not to say one ethanol or ethane, one ol or ethanol, one, all is not necessary. So, ethanol can be prepared by the hydrolysis. Here you can take a potassium hydroxide, sodium hydroxide, calcium hydroxide, some weak base or strong base, but dissolved in water. If it is alcoholic, KOH is taken, elimination leads to give the alkene formation. The second one is a reduction of carbonyl compounds. Reduction of a carbonyl compound. Here also we have a carbonyl compounds, two varieties. One R containing a carbonyl compounds is called aldehydes. One H, one R is aldehydes. If you take an aldehyde, reduce with the hydrogen in presence of a nickel, it slightly heat it, the two hydrogens added, one here, and you are going to get a 1 degree alcohol. All different types of the aldehydes are going to get definitely 1 degree alcohols. Okay. Now, if you have a carbonyl group attached with both the sides alkyls only, no hydrogen. So, this is called a ketone. It is a common example for a ketone. If two alkyls are methyls, it is called acetone. The acetone and similar reduction gives the a 2-hydroxy, that is a OH attached to a 2 alkyl. So, therefore, it is called a 2 degree alcohol. So, you can have a standard statement that 1 degree alcohols are prepared from one of the aldehyde reduction. If you want a ethanol, you take ethanol or acetaldehyde reduction. A 1-propanaldehyde. Okay. Similarly, if you want a 2 degree alcohols, you have to choose a suitable ketone. If acetone is taken, you will get a 2-propanol or isopropyl alcohol. In this method, you cannot prepare a tertiary alcohol. In the previous method, if you have taken a 1 degree alkyl halide, 1 degree, 2 degree, 2 degree, 3 degree, 3 degree, you will get it. Whatever the type of alkyl halide, you will get the same type of the alcohol. But here, it is the limitation is there, 3 degree alcohols, you can't prepare by this method. Okay? 3 degree cannot be prepared in this method. We have a subsequent some methods where 3 degree alcohols also can be prepared. Now, let us go for the third method. In the third method, we will take one carbonyl compound is used. In addition to that, one RMGX, which is commonly known as what? Grignard reagent. Grignard reagent. Grignard reagent. This reagent, after adding a salt is formed, the salt needs a hydrolysis with the acidified water, then alcohol is formed. Okay. So, now here also, as I said, it can be used for the 1 degree, 2 degree, 3 degree. Under what condition 1 degree comes? 1 degree will be prepared provided if you have both hydrogen. This is nothing but the only formaldehyde is eligible for this method. If you take formaldehyde, add any RMGX which you like. You can take ethyl, methyl, propyl, iso, and so on. Aromatic also you can take. The R minus happens to add on the C plus. Magnesium adds on the O minus. This is minus, this is plus. Therefore, minus adds, plus adds on the O. So, subsequently, you will get a salt. O with the OMGX and R is added to the carbon. O will become OMGX. This is a salt of the 1 degree alcohol. Isn't it? R is there, CH2, O minus and 1 degree alcohol magnesium salt. This on hydrolysis step, you will get the RCH2OH. This is nothing but a 1 degree alcohol. Now, tell me, if you want methyl, if you want ethyl alcohol, what is the method means? You take formaldehyde, add methyl magnesium chloride. The methyl plus 1 more carbon, you will get 2 carbon. In this method, except the methanol, all types of 1 degree alcohol can be prepared. all types of the 1 degree, exception is only for the methyl alcohol. The second method is you have to choose an aldehyde, but not the formaldehyde. This you can generalize as any aldehyde except formaldehyde. Except formaldehyde, you can take any aldehyde. Similarly, you add RMJX and hydrolyze it. You will get a salt. The salt will contain two R's, one is old R, another is from the RMJX, one hydrogen, so OMGX is there. You hydrolyze it, you will get the two R's containing alcohol. This is nothing but a 2 degree alcohol. 2-propanol, 2-butanol, and so on, different types of the 2 degree. Now, similarly, if you have to select a ketones for the reduction purpose, so you take one ketone, any ketone you can write, any ketone, but it must be a ketone, 2 alkyl containing carbonyl compound, and adding the RMJX followed by the salt formation, and then 2 R's are already there and third R is coming. So, OMGX will be formed, a salt of the tertiary alcohol, which on hydrolysis, acidic hydrolysis makes the alcohol containing the 3 R's, means it is a tertiary alcohol. So, to prepare tertiary alcohol, carbonyl compound should be a ketone. To prepare 2 degree, carbonyl compound can be any aldehyde excepting because formaldehyde is going to give the 1 degree. So, all these 3 the types of the alcohols can be prepared in the third method, right. Now, in the fourth method, hydration of alkenes. Hydration of alkenes. This is also a simple method. Alkenes means a double bonded compounds. If you are taking, you add the water, HOH addition is known as hydration. So, the alkenes, however, simply you cannot add water. If you add water, even in boiling also, you won't get this reaction. You need a few quantity of concentrated H2SO4. This is a catalyst used. But however, several books also can code like this: the mixture of water, reagent, and few drops of concentrated sulfuric acid together is nothing but the dilute H2SO4. Temperature is at room temperature only, no heating is required. In fact, if you heat it, the reaction may be coming back also, because alcohols on heating gives back alkenes. So, therefore, at room temperature you take water and alkene, a few drops of sulfuric acid you add it, and simply the HOH will add, one side H will be added, one side OH is added. So, ethanol is formed. In this reaction, we have a small mechanism. In fact, water will not readily split up and add as a plus minus. Sulfuric acid proton will be first added, then the whole water is added. From the water, one H comes and goes back to the sulfuric acid. So, net is a H and OH addition. Only thing is, this H is not water H, it is sulfuric acid H. The proof is, if you take D2SO4, you get a D here. Similarly, if you take D2O, it is not D and OH, but H from sulfuric acid, OD from the OH is added. That is the proof or evidence for this mechanism. Hydration of alkene. Different alkenes you can take, provided if you have a propene, for example, you are going to get a 1,2-propanol following the Markovnikov rule, isn't it? We have certain methods to prepare 1-propanol also. First, add HBr following anti-Markovnikov rule, you will get a 1-bromo. HBr in presence of the UV light or hydrogen peroxide will give a 1-bromo compounds, that on hydrolysis will give a 1-propanol. So, but ordinary method hydration following Markovnikov rule, you will get a 2-propanol. And we have some methods like if you take carboxylic acid, reduction of the acids and acid derivatives also, RCOOH. This on reaction with the lithium aluminum hydride. This is a metal hydride. It's a combination of lithium hydride and aluminum hydride. When you add the Li plus and H minus will be added, and this OH will become 2 OHs, eliminate water. Subsequently, you will get an aldehyde. The aldehyde further undergoes a lithium and the H addition. It will become a 1 degree alcohol salt, which automatically hydrolyzes to give the 1 degree alcohol. So, the acid will give 1 degree alcohol. The acid, if it is 2 degree, 3 degree also, you will get 1 degree alcohol only. So, reduction of carboxylic acids will give the 1 degree alcohol. In addition to the alcohols, you can take acid chlorides, acid anhydrides, CO, OCOR. You can also take RCOOR. All these compounds undergo reduction to give the alcohols. Any one of the acid derivative except amides. Amides will give 1 degree amines. So, therefore, acids and acid derivatives you will get the 1 degree alcohol. Lastly, we have one common method also, that is a RNH2, that is a 1 degree aliphatic amines. Aliphatic amines, if you take, they react with nitrous acid H1O2. This is actually a acid which is unstable, not available in the market, which can be generated by taking the sodium nitrate NaNO2 plus HCl. If you add, this generates this acid, and this reacts. Finally, what comes is a ROH, and nitrogen is liberated out, and the alcohol can be prepared. Methylamine will give methanol, ethylamine will give ethanol, and so on. The same reaction, if you take an aromatic, you will get a diazonium types of the salts, but in the aliphatic case also you will get diazonium, but decomposes to give the alcohols. So, all these 6 methods are very good methods for the preparation of the alcohols. Especially in the case of ethyl alcohol, we have one commercial method also, which is also asked in the examinations frequently, that is from the molasses. The molasses is nothing but the mother solution after preparation of the sugar, the leftover solution which from which you cannot extract the further extraction of sucrose is not possible. Almost 60% of the uncrystallized sucrose will be there in this one. It is diluted 5 times. If you 20 ml, if you make it to 100 ml, 5 times it is diluted and added some yeast and kept for 2 to 3 days. It is a slow process. At around 30 degrees centigrade, the yeast grow a small quantity of the ammonium sulfate to increase the nitrogen content, and a few drops of sulfuric acid will be added to destroy the other bacteria. Now, this slowly, yeast is a fungal material, unicellular fungal material, grows in the form of a threads, but yeast slowly develops by hydrolyzing this molasses, and the energy released it will be using. From the molasses, what contains here is sucrose. It is a sucrose is there in this molasses. The sucrose is nothing but a dimer of glucose and the fructose. So, therefore, this sucrose is going to hydrolyze, and you will get the glucose and the fructose. Both these 2 molecules further hydrolyze to give the ethyl alcohol. So, this is the what is happening. First, the sucrose is converted to glucose fructose by the enzyme produced by the yeast called invertase. ASE stands for the enzyme nomenclature. Invertase means this will have a positive optical activity. The mixture will show the negative optical activity. That is why the name invertase. Otherwise, actually, the glucose it is working there, on the sucrose it is working, therefore the same one you can call it as sucrase. On which it is working, you attach ASE, the name will come, because enzyme will be so long, you cannot apply a nomenclature of IUPAC. Sucrase or invertase converts sucrose into glucose and fructase. After that, zymase, another enzyme will convert glucose fructose into ethyl alcohol. In the ethyl alcohol, approximately 10% ethyl alcohol will be there, that is called wash actually. The wash is the distilled fractional distillation will give around 95.6% alcohol. This alcohol is called rectified spirit, in which the water will be there, remaining 90% will be water. That 90% water you cannot separate by fractional distillation. Here you have a that is still 4.4% water is there, that you cannot distillate, because that 95.6% alcohol and 4.4% water makes a azeotropic mixture. This azeotropic mixture will boil at around 71.2 degrees centigrade to give again mixture only. How many times you distill also, you will get the mixture only. Such a type of mixture is called azeotropic mixture, which you cannot distill, you cannot separate by the distillation process. You have to use some chemical process, like you add some calcium oxide, slightly heated calcium oxide, or you can use some magnesium ethoxide, ethanol salt of the magnesium. Magnesium ethoxide or sometimes magnesium foils also can be used to absorb this 4.4 water will be absorbed by these chemicals. Once again you distill. After treatment overnight you keep it and then distill, you will get 100%, almost 99.99% or 100% alcohol is known as what? Absolute alcohol. This is the method we are using commercial the production of the ethyl alcohol. Now let us go for some properties of the alcohols. Alcohol's properties have got some arithmetic understanding. When once there is some arithmetic procedure, you can understand very easily, and also you can remember for the longer time. We have basically two types of the reactions. One is the hydrogen breaking from the O and the oxygen breaking from the carbon. So there are two types of reactions. First, fundamental reactions, these are breakage of the hydrogen and breakage of the OH from the alcohol. And third type of reaction is there are some reactions which are taking place in the alkyl group influenced by this OH group. So there are three types of reactions are there. In the first type, once again we are having the A, B, C, D, four types of reactions are there. First one may be called as acidity. Second one, ether formation. Third one, ester formation, and oxidation. These are the four types of the reactions. The second also we have three reactions are there. The OH can be replaced by halogen, so therefore halogenation, and the OH and H removed, that's called dehydration. OH can be replaced by H, called reduction. Here there is only one reaction, that is haloform reaction. So totally we are going to see now 4 plus 3 7 plus 1 8 fundamental reactions are there. If you are having thorough with these 8 types of the reactions, I think most of the properties of the alcohols are covered. Now let us go to this acidity. That is breakage of the hydrogen from the alcohol, and in which the hydrogen is, if it is given out as a H plus, the point of that is explanation is how best the H plus comes means, really speaking, alcohols are not far for the donation of the proton. When this type of the reaction is possible means, when this OH is attached to the benzene, for example, this is known as phenol. Phenols like to donate the proton because the so-called the anion formed in the case of phenol, the phenoxide is formed, right? You can write OH here or there. The phenoxide formed after donation of the proton has a resonance stability. Therefore, the process is ready. So, I can ask a question, in which of the following the proton will be liberated easily? Alcohol or phenol or ether, means ethers cannot donate. These two have a chances of which the phenols donate the proton. That too, comparatively phenols are weak acids. So, therefore, phenols are weaker acids. When compared with the carboxylic acid, they are weak. But when compared with the alcohol, they are stronger acids. Alcohols also show some acidic character, slight acidic character. When you treat it with sodium metal, alcohols are becoming into the alkoxides. Metals like sodium, potassium, if you add, they become into the alkoxide, and the hydrogen gas is liberated. In this reaction, alcohol is behaving like this is an acid, this is a base, right? But the how best you have, how much quality is there, means very small quantity of the alcohol, because the alcohols after donation of proton, alkoxide formed, have no more the stability of the resonance. Therefore, moreover, the R is a plus I group, it destabilizes the O minus, therefore, the reaction is not favorable. However, going to the B, that is ether formation, right? Ether formation is a very good reaction. Ether formation requires there is some confusion in the reaction. So, let us have some elaborated explanation. Ethyl alcohol has three fundamental reactions, with the same sulfuric acid. In all the three cases, we are using concentrated H2SO4. All the three cases, reaction is with the sulfuric acid only, but the difference is different temperatures. One is around 70 degrees centigrade, this is at 140 degrees centigrade, this is at 170 degrees centigrade. Okay. Now, at 70 degrees centigrade, ethanol converts into ethyl hydrogen sulfate. So, this part is called sulfate. So, how do you call ethyl hydrogen sulfate? What is going to happen here? The sulfuric acid OH, and this OH is eliminating water. Therefore, sulfuric acid is linked to the alcohol. It is a sort of nucleophilic substitution of sulfate anion with the OH. Therefore, this is forming. If it is 140 degrees, two alcohols will undergo elimination, and you will get a alcohol is attached to the another alcohol, that is called ether, diethyl ether. And when you heat it at 170, one H from the same alcohol and the OH is removed. In the third case, alkene is formed. See, all these reactions eliminate water molecule. These are all dehydration reactions. However, the dehydration is not common. Only in the third case, we are calling dehydration, because from the same molecule HOH is removed. In the case of ether formation, two alcohols are involved, intermolecular dehydration this is. In the case of sulfuric acid, between the sulfuric acid and alcohol, water is eliminated. In all the cases, water is noticed. Okay? As the temperature you change, all these three products are formed. However, we have small confusion also. What is here means, if you want to prepare ethylene, what is the method means, I will take alcohol, add sulfuric acid, heat it 170. But can you heat 170 all of a sudden? No, we have to go through the 70. Then further heating will come 140. At further heating will come 170. All of sudden 170 will not come. At 70 degrees, open the flask and see, this will be there. At 140, open the flask and see, it will be there. That means this reaction is the real reaction. So, suddenly coming ethylene is no more exists actually. Therefore, these two reactions need not to represent at all. It goes to the ethyl hydrogen sulfate, further heating gives diethyl ether, further heating gives the ethylene. It is also correct to say that ethylene, when you take add water, adding concentrated sulfuric acid at room temperature. If you add water and sulfuric acid at room temperature, this ethyl hydrogen sulfate is added. Similarly, the ethanol, if you heat it at 170 degrees if you heat it, this ethyl hydrogen sulfate will become again removal of the water, again you will get it. Ethanol if you add water in presence of sulfuric acid at room temperature, the water will be added, you will get HOH, right. Here only sulfuric acid, you add sulfuric acid at concentrated sulfuric acid at room temperature, you will get this ethyl hydrogen sulfate. This ethyl hydrogen sulfate you can also prepare ethanol by heating with water. Add some water and heat it, ethyl hydrogen sulfate hydrolyzes to give the ethanol. So, within the inside there is a temperature reactions, outside this is the room temperature reaction, this is the room temperature, this is also room temperature. But interconversions all are the example that is excellently you have to remember they are all interconnected reactions. If ethanol is taken 140 ether, you further heat it, you will get ethylene plus sulfuric acid at room temperature, ethyl hydrogen sulfate, add water at room temperature, you will get ethanol, and so on. They are all interconvertible reactions. Main reaction what we are studying is ethanol at 140 degrees diethyl ether. This is called ether formation. Right. Now let us go for the another property called ester formation. Third property let us see. Third property is ester formation. Third property. Alcohols react with the carboxylic acids or COOH. The reaction is catalyzed by the concentrated sulfuric acid. If you add concentrated sulfuric acid, the reaction gives HOH elimination or HOH elimination. Somehow the water is removed and you are getting a R with CO, R with OCOR, R with OCOR. This is called ester. What is removed is nothing but the water. Now the question is which OH is going out? If the alcohol is 3 degree 1, if the alcohol is 3 degree 1, OH of this one is removed. OH from this side, H from that side. If the alcohol is 1 degree, H from alcohol, OH from the acid is removed. Because if 3 degree alcohol is taken, if OH is removed, 3 degree carbocation comes, which is a stabilized one. Therefore, mechanisms may also be the question. Lastly, the oxidation is ethyl alcohol undergoes two types of the oxidation. One is heating with the copper at 300 degrees. This is called mild oxidation. In the mild oxidation, what happens? One H from here, one H from the here removed, and you will get a carbonyl compound with one hydrogen, that is liberation of hydrogen is removed. The reaction nothing but the oxidation because removal of the hydrogen. It is also called specially dehydrogenation. Dehydrogenation. What is the role of catalyst? Catalyst is supporting for the removal of the hydrogen. It is no compound formation, you see. Copper will become copper only, but the hydrogen gas is and the observed to liberate. If the compound is treated with dichromate or potassium permanganate K2Cr2O7 in presence of the dilute sulfuric acid H plus, the compound becomes first actually HH plus nascent oxygen liberated here will be removed as H2O, compound will become into an aldehyde actually. But the aldehyde will not be the final compound. This will be further oxidized with a nascent oxygen. The oxygen will be coming here. The compound will become OH and the CO, that is a carboxylic acid comes. In this acid formation, if the 1 degree alcohol is taken, there is no loss of the carbons you find. If the 2 degree alcohol is taken, compound cuts and becomes into two different acids. 3 degree alcohols restore, that is resist for this type of the oxidation. Even in the copper 300 also, we have one specific observation depending upon the nature of the alcohols. If the alcohol is a 1 degree, say OH and H is there, then the copper 300 will give the aldehydes, right. This there is one more H, the H, this H I have written. This is 1 degree, then the aldehydes will come. If it is 2 degree, what happens? Okay, 2 degree means one carbon is there, OH I will write. This is a 2 alcohol, again HH will be removed, you will get a ketone. it is a ketone, right? Here aldehyde is formed. 1 degree alcohols, similar the case reverse reaction just we have seen, aldehyde and reduction gives 1 degree alcohol. Now 1 degree alcohols with a copper 300 gives aldehydes. Here the reaction is copper at 300 degrees, oxidizing agent this. In both the cases oxidation is taking place, hydrogen is liberated. Hydrogen is liberated. This is a oxidation step. But if 3 degree alcohol is taken, 3 degree alcohol has no hydrogen to remove the H and H. Instead, hydrogen from the next carbon is removed and you are getting a dehydration, alkene is formed. Alcohol to alkene means the chapter is going back, that's a reduction taking place. In the reduction, what is happening? H2O is formed. Alcohols are demoted back to the alkenes, means it is a reduction. If the chapter goes forward direction, aldehyde to acid, it is an oxidation, isn't it? Alcohol to aldehyde, aldehyde to acid, it is an oxidation. So here alcohol becoming aldehydes, ketones, oxidation. Alcohol becoming alkene, that is a second chapter alkene, isn't it? So therefore it is a reduction. See the difference, 1 degree, 2 degree showing oxidation, but the 3 degree showing the reduction, right? So this is called a oxidation concept. Halogenation. In the halogenation, alcohols can be converted into the RX. What type of halogen means? If you want to use the chlorination, you have reagents like PCl3, you have PCl5, you have SOCl2, you have HCl, concentrated HCl, and anhydrous zinc chloride. This particular reagent also we have seen Lucas reagent. This reagent has an application. What is that? The reagent, when you add, after taking the reaction, the alkyl halide formed has a turbidity formation. 1 degree undergoes faster, slow reaction, very slow, absolutely, and 2 degree gives 5 to 10 minutes, 3 degree gives immediately. So therefore, the fastness of the turbidity formation gives a clue what type of alcohol you have taken. If it is tertiary alcohol, within no time you will get the turbidity. So therefore, given alcohols, a set of alcohols may be given asked, which of the following alcohol gives the fastest? If it is tertiary, you mark for the tertiary. These are all chlorinating reagents. For the bromination, we have PBr3 as well as HBr. In the case of HCl, you need a catalyst, but in HBr, directly you add HBr, you get the bromo. For the iodination, even all these iodo products are not there, only the I2 in presence of the phosphorus is the catalyst. I2 and the phosphorus is the catalyst for the iodination. Hi, if you use, that's a bad. Hi decomposes into H dot and I dot. That I dot will alkyl iodides are reduced to alkanes. So Hi or Hi in presence of the phosphorus, both are reducing agents. So therefore, you should not use them for the iodination. Iodine in presence of phosphorus is the iodinating agent. You can convert all alcohols into their corresponding halogen, especially if ethanol, if you take ethyl chloride, means the best reagent may be PCl5 or PCl3 or a Lucas reagent. Thionyl chloride, SO2Cl2 is called sulfuryl chloride. This is thionyl. The SO is sulfonyl chloride or thionyl chloride is the reagent. Now coming to the dehydration concept. That is in the second type of reaction, dehydration. Alcohols, when you heat it with the, already we have taken this concept, when you add concentrated H2SO4 at 170 degrees or beyond 140 degrees, the reaction is HOH will be taken away, the water goes to the sulfuric acid, H plus is given, it will become H3O plus, the compound will become alkene. Right? The reaction also can be taken up by the using the Al2O3 at around 350 degrees centigrade, you will get this reaction. 350 degree centigrade, heat it. Alumina, you take the alumina, send the vapors of alcohol over alumina at 350 degree centigrade, dehydration is taking place. Dehydration has a mechanism, as I said, the proton attack on the OH, water will be dropped, a carbocation comes, then the H is dropped, double bond is formed, the carbocation leads to give the rearrangements and so on in this particular concept. Reduction is alcohols, ethyl alcohol, when you add the HI, as I said here, HI when you add, HI decomposes, 2 HI decomposes into 2 H dot plus 2 I dots. 2 I dots immediately join up, you will get I2, but the 2 HI will be loitering in the reaction, that will add on this, you get a breakage of this bond, and the H and H will be added. So, this becomes into the water and this becomes into the alkane. So, alkanes are formed when alcohols are reduced with HI and in presence of phosphorus or HI, if you add, the reduction taking place. Now, lastly, haloform reaction. In the last chloroform topic, this haloform reaction in length and depth we have discussed. All alcohols containing the 2 degree type 1 2 hydroxy, from this side it is 2 hydroxy, the H and H will be dropped. You can also have some alkyl group, but the HOH present should be there, so that first if X2 is used, the 2 moles of HX is formed, the compound will become a carbonyl compound, then the hydrogens present will become into a trihalo compound. This trihalo compound undergoes the hydrolysis, you will get CHX3. If it is chlorine is used, you get a chloroform. If a bromine is used, you will get a bromoform. If iodine is used, you will get a iodoform. In the case of iodoform, iodoform is a yellow crystalline compound, and commonly the test is known as haloform test. So, the all alcohols when subjected for this iodine and KOH are bromine and the base, or chlorine and the base. Base can be a sodium hydroxide, potassium hydroxide, or calcium hydroxide. The same type of the haloform is formed. In the case of iodoform, yellow crystalline product. In the case of bromoform, brown colored liquid is formed. Chloroform, however, unfortunately, it has no color, it is a liquid, so therefore stoichiometrically you cannot use this reaction for the calculation, but for the iodoform is a yellow colored and it is a solid, therefore it can be used for the estimation of the 2 hydroxy compounds or 2 keto compounds can be estimated. So, this is all about the alcohol's properties. Let us go for the some of the questions which are asked in the previous years, and also some important questions which are expected, we will see now. First question. So, in the brackets we find the in which year it was asked also, it is mentioned EAMCET 2006 question. It is when compound X is oxidized by acidified potassium the dichromate. As I said, the alcohols on oxidation gives the carboxylic acids. Now, the compound Y is an acid. The Y acid on reduction with lithium aluminum hydride, again you will get back the ethyl alcohol. So, therefore, Y and X are acid and alcohol, but the question is X and Y asked. Okay? X and Y means X is a alcohol. X is the final compound, ethyl alcohol. Y is in between compound, acetic acid. So, the answer 1 is the right answer. Go for the answer. Answer 1 is that is ethyl alcohol is final answer. The acetic acid is in the middle answer. Next. In this question, ethyl alcohol is treated with chlorine. Step 1. You got ethyl alcohol oxidation to give the chloroform, that is this is the preparation of, in fact, a chloroform. 2 steps it is. The first step you will get the oxidation step. Ethyl alcohol is becoming into an oxidation step, carbonyl compound. Carbonyl compound and further chlorination, trihalo compound is formed. So, that was shown here. Now, here in above reaction, the role of chlorine in step 1 and step 2. In both the cases it is oxidation, in fact, but the option 2 oxidations are not given. First step oxidation, second step chlorination or halogenation you can go for. So, the answer 1 is the right answer. In fact, the second step is also oxidation step only. Halogen entering, hydrogen going means it is an oxidation. Next. Identify A and B in the following reaction. A with aqueous NaOH giving ethanol. So, maybe the A is ethyl chloride aqueous NaOH substitute the OH, substitute the Cl, so you got ethyl alcohol. Ethyl alcohol also can be prepared from the B also. The reaction is reversely shown. Silver hydroxide or moist silver oxide hydrolyzes to give the silver hydroxide, that OH also replaced, you will get the ethyl alcohol. So, in both the cases the A and B are the nothing but the ethyl chloride, that is answer goes to the D, that is 4. Answer 4 is the right answer. Next. In the reaction, ethyl alcohol vapor is taken. I said just now in the oxidation reaction, ethyl alcohol is passed over the copper 300 degrees. This is a dehydrogenation reaction. 2 hydrogens are dropped from the last carbon, that is hydrogen is removed out, and it is an oxidation to give the acetaldehyde. The formulas are given, however, acetaldehyde is 2 carbon, 4 hydrogens oxygen, that is third option is the right answer. Yes. Next question. Which of the following is a secondary alcohol? As I said, secondary alcohol means the alcohol, the OH attached carbon, if one alkyl group is there, it is 1 degree alcohol. If 2 alkyls are attached, it is 2 degree alcohol. See the first case, that is you have to able to write the structural formulas of the compounds given. By name, it may be misleading. It is 1 propanol, 2 propanol is not the method of identification. As I said, the first one is 2 methyl 1 propanol. It is a propanol containing 2 methyl 1 propanol. This is A. So, here OH attached the carbon, how many alkyl groups? 1 alkyl group, 2 hydrogen. So, therefore, it is a 1 degree alcohol. Second option, 2 methyl 2 propanol. 2 propanol means OH is on the second carbon, 2 methyl. So, OH attached carbon is attached with the 3 alkyls. So, 3 alkyls attached carbon is a 3 degree one. But in the nomenclature you have a 2 propanol. 2 propanol gives it is a 2 degree. Okay, wrong. 2 butanol. 2 butanol means a butane with the 2 OHs. Okay, here comes the 2 and 2 coinciding, but that is not the classification. 2 propanol means 2 alkyls and 1 hydrogen. This is 2 degree. The lastly 1 butanol. 1 butanol means but with OH. So, it is OH attached carbon has 1 alkyl and 2 hydrogen, therefore, it is a 1 degree. You must be able to recollect the structure of the compound. Here IUPAC nomenclature is given. Instead of 2-butyl alcohol may be called as secondary butyl alcohol. Secondary butyl. If in fact the nomenclature is a radical functional nomenclature, 2-butyl alcohol. So, this is alcohol containing a secondary butyl. Secondary butyl, the nomenclature itself, it is secondary carbon on which OH attached. So, if this name is given, we can easily identify in fact. Next, go to the next question. Answer is 3, therefore, 2-butanol is the 2 degree alcohol. Next. The IUPAC name of unsymmetrical ether with the molecular formula C4H6O. C4H6O. So, unsymmetrical ether means this question is actually from the ethers topic it is, but the question C4H10O. Okay. Here you have to make a ether. Ether means ROR. Unsymmetrical means out of 4 carbons, you take 3 carbons one side and the 1 carbon one side. So, you will get a methoxypropane will be the right answer, methoxypropane. The propane can be this way also. Okay. This is a 1, 2, 3. You have to say systematically, actually the name is given some methoxypropane, but methoxypropanes are 2 types. This is 1 methoxypropane, this is a 2 methoxypropane. Can you tell me what is the isomerism between these two? 1 methoxy, 2 methoxy. If it is a halogen, 1 chloropropane, 2 chloropropane. Positional isomerism. This is a positional. We have one point here. People think it is a chain is a reversed. Straight chain, branched chain. Therefore, it is chain isomerism. It's wrong. It's a misleading type of the concept here. It is the positional isomer. 1 methoxypropane, 2 methoxypropane. Clearly, it is a positional isomer. So, methoxypropane is the right answer. Next. 7th question. In the following reaction, X and Y respectively are. So, ethyl alcohol with permanganate gives a carboxylic acid. X is a carboxylic, because it's a strong oxidizing medium, gives acids. If a copper 300 is taken, you could have get a aldehyde. So, the acid is treated with Y, so that ester is formed. So, acid with Y means Y must be ethyl alcohol. So, therefore, X is acetic acid, Y is ethyl alcohol. Search for the answer. 4 is the right answer. So, acetic acid, and then it is treated with the ethyl alcohol, ester is formed. Second step is the esterification step, first one is the oxidation step. Next, which one of the following is a secondary alcohol? Once again the question is on the classification, the alcohols, the classification. The secondary alcohol means OH attached carbon should have a 2 alkyl groups. 2-methyl 2-propanol, this is nothing but the 2-methyl 2-propanol, it is a 3 degree. 1-propanol 1 degree, 1-butanol 1 degree. 2-pentanol, 2-pentanol means if 5 carbons are there having a OH on the second, OH attached carbon has a methyl group and N-propyl group, so therefore it is a 2 degree. Okay, provided if you have this clarity in the structure, when name is given structure, structure is given name, vice versa, if you are thorough, isn't it? This classification can be possible. Nowadays, the question from the nomenclature, question directly what is the name of the compound, such questions almost disappeared. The questions like this, there may be some based on the classification or based on some reaction. X gives Y. Y, what is the nature of this Y? Okay, what is the IUPAC name of this Y? He links the nomenclature with some reaction. Pure nomenclature questions is no more coming. In the recent years, no such a pure nomenclature questions are not coming. You must be thorough with the nomenclature, so that name is given structure, structure is given name, you must be able to transform. Then you identify the what type of the alcohol is asking. Okay, right. Next. The 9th question. Which of the following pairs of compounds are functional isomers? See, again it is an isomerism question, but we have an alcohol and another alcohol, alcohol versus alcohol. So, the chain is changed, therefore, it is a chain isomerism. Second one is alcohol versus alcohol. Again chain is changed, it is a chain isomerism. The third one, alcohol versus halogen. So, the molecular formula will be different, so they are not isomers at all. In the fourth one, it is a alcohol versus ether. Alcohol is a 1-propanol, ether is a methyl ethyl ether. So, their formula is same, one is alcohol chapter, the other one is ether chapter, therefore, functional group is different, therefore, answer 4 is the right answer. Next. Ethanol when reacted with PCl5. As I said, in the chlorination reaction, we have an option of chlorinating agents like PCl5 and PCl3. POCl3 is a byproduct. PCl3 and PCl5 and HCl with the concentrated zinc chloride and the SOCl2 are the chlorinating agents. So, he asked ethanol when treated with PCl5, gives a and POCl3. And HCl, these are the 3 byproducts, 2 byproducts, 1 product is given. The product is a ethyl chloride. A, that is ethyl chloride reacts with silver nitrate. As I said in the ethyl chloride topic, ethyl chloride with potassium nitrate and sodium nitrate, answers will be nitrites only. Silver nitrate will give a nitroalkane, NO2 group will come. Reverse is true here, and therefore, the B is the nitroethane and the A is the ethyl chloride, that is ethyl chloride nitroethane is third option is the right answer. Next. 3 moles of ethanol reacts with 1 mole of phosphorus tribromide, it is a PBr3, and 3 moles of bromoethane subsequently formed 1 mole of X, that is byproduct here. PBr3 after reaction what happens? PBr3 when treated with the ROH, what happens? You have to balance like this, all OHs will go here and all BRs will come here. So, therefore, here 3 moles of RBRs will be formed, but what about the P? P will get the 3 OHs in fact. This is nothing but the H3PO3. H3PO3 is called a phosphorus acid, H3PO3, that is 4th one, right. Absolute alcohol means 100% alcohol is prepared by distilling rectified spirit. Rectified spirit means 95 point, that is percentage. It is some water will be there in the rectified spirit. To remove this water, ordinary distillation or the fractional distillation will not be useful because azeotropic mixture is formed. You have to treat with a chemical reagent like either the magnesium ribbons, third one, or magnesium ethoxide, fourth one. Actually, the fourth is the here the option is given, but even magnesium ribbons in some books it is given. Either the calcium oxide, a heated calcium oxide also works here. Next, which of the following is Lucas reagent? It is a mixture of anhydrous aluminum zinc chloride and concentrated HCl, which is used for the halogenating the alcohols. As I said, this is a differentiating reagent also between 1 degree, 2 degree, 3 degree alcohols, because 3 degree alcohols gives fastly the turbidity. There is an exception like a allyl alcohol. Allyl alcohol is a 1 degree, but gives a faster reaction because the carbocation undergoes a resonance stability. Even benzyl alcohol, which is also a 1 degree alcohol, an exception is there. Benzyl alcohol gives a benzyl carbocation intermediate, which also gives a faster reaction with the Lucas reagent. Exception, these two are. Next, which of the following is a tertiary alcohol? The structures are given. Some work is less here. You have already structures written here. If the names are given, you have to convert into structures, but the structures are given. The last compound, you see the OH attached with the carbon with 3 methyl groups is the last answer. Fourth one is the right answer. Yes. Next, absolute alcohol is prepared by distillation of rectified spirit in the presence of magnesium ethoxide. Just now we have answered. Third one is the right answer. Calcium carbonate, calcium hydroxide, calcium chlorides makes a salts with the absolute alcohol, therefore they are not recommended. Calcium oxide is recommended. Magnesium ribbons or magnesium ethoxide is the recommended one. Next, the alcohol that produces turbidity immediately with Lucas reagent, concentrated HCl, zinc chloride at room temperature, is a tertiary alcohol. You search for the tertiary alcohol, that is nothing but the 2-hydroxy 2-methyl propane. A propane containing the 2-methyl 2-hydroxy. This is one, it is a 3 degree one. As I said, Lucas reagent is the tertiary alcohols, gives fast reaction. This is a question of 97. So, it is a question repeated concept, but this concept is several times is coming. Lucas reagent is used whenever you use the tertiary alcohols, gives immediately turbidity. The turbidity is because of the halogen compounds formed are not soluble in the aqueous media, therefore turbidity comes. Next, the compound here reacts with PCl5. Must be alcohol with PCl5B, means the ethyl chloride is formed. On treatment with KCN, ethyl cyanide is formed. The cyanide on hydrolysis gives a propanoic acid. The product A is, that is ethyl chloride. He is asking, ethyl chloride is the ethyl alcohol becomes ethyl chloride. So, alcohol is asking. So, the fourth answer is the right one. Next, alcohol manufactured from the water gas. Water gas is when you take the red hot carbon and send the vapor, and the carbon and the H2O reacts and forms H2 and CO, carbon monoxide and H2. These two mixture will give the methanol, so therefore answer is the methanol. So, third option is the right. Next, the IUPAC nomenclature of this one, it is a butanol containing 2-hydroxy, the numbering from the hydroxy, therefore methyl will become 3. 3-methyl 2-butanol. 3-methyl 2-butanol is the right answer, answer 3. Yes. Next question, perhaps it is the last question. Ethyl alcohol, when passed over copper at 300 degrees, is dehydrogenated to give. As I said, copper and 300 is an oxidizing agent in the case of 1 degree and 2 degree. However, 3 degree compounds undergo dehydration. So, this is a oxidation of ethyl alcohol into the acetaldehyde. If you see that the just what I explained will almost covering the entire questions. So, therefore, a brief study of the brief study of the all the properties of ethyl alcohol and preparations. If you are thorough, there cannot be a question you cannot answer. Okay, all the questions you can answer, provided you must have a thorough knowledge on the subject first of all. No need to by heart. There is no need to by heart. People say if you by heart you can answer, but it's wrong that you know the concept. Any question you can answer. If you by heart, only certain questions you can answer. So which is the best, you have to think over. Thank you.